Okay, so this time I'll be mentioning about Unit 33. So there'll be two parts for this videos. The first part will be basically theory. I will let you know which parts you have to memorize and which parts you don't. So I'll go through everything as much as I can, and I'll make it as brief as possible so you don't have to spend too much time watching this video. Okay, so let's start with this chapter. Will talk about we'll learn about organic substance, some commonly used organic substance that we find in our daily lives and in daily products. So let's begin. The first one, okay, this is on page 172, is aspirin. Okay, aspirin is a common painkiller. So it's been used, as you see, it's over 100 years. So it's the very first time was used, and many people were using it in the past. And there are some side effects, which we'll go through it a bit later. So first, let's look at the structure. Now, since you have learned all the basic functional groups, you are able to identify this relatively easily. So salicylic acid over here, you can see. So I just drew it again, and you can see there's a benzene ring, all right, over here. And then you will see this part over here, it's COOH, so it's a carboxyl group. And then we also have COO connected with a chain. So this one is an ester group. Now the name aspirin, it's a commercial name, okay? So what is the active ingredient that relieves the pain? Is actually this thing. So it's called acetyl salicylic acid, okay? Or in other words, it can be called 2-ethanol oxybenzoic acid. But I prefer you to memorize this name because this name will be popping out quite a lot. And do you have to memorize this structure? Yes, you have to, because in DSC 2012, it has been asked once. So it's been 5 years, it's not been asked, so it's possible that in your year, they will ask. So it's really easy. So it's the first one and the second carbon. One is connected with COOH, and one is connected with COO and a C here. So it's an ethyl group over here. And that's it. Now over here you'll see in the textbook on page 173, it talks about why you take aspirin and the problems with aspirin. Read it on your own. Chemistry exams, they will not ask, okay? Okay, next thing in our daily lives will be detergents, okay? On page 174. So let's get on with it. So detergents, so I just made quickly notes over here. Detergents are used because it improves the cleansing properties of water. So water itself sometimes cannot wash away dirt or oil. Okay, even as much as force you use, it's really hard to remove those. So therefore, detergents were invented or found to increase the cleansing properties of water. Because normally what happens is that, okay, this is theory part. You don't really have to memorize the whole paragraph. So I'm just going to quickly go through. So just look at this picture over here. I'll explain quickly. Normally, if you have droplets of water on a fabric or clothing, you will see these water bead up on the surface like this. Now it's because of the properties that you've learned in the very beginning, because of high surface tension. And because of this, it really prevents the cloth to be wet completely, okay? So you can see over here, it slows down the wetting of the surface and inhibits cleansing process, okay? So highlight this part, please. And so because when you're cleaning, you want to reduce the surface tension so the water can spread, okay? Because of the high surface tension, the water is making in a bead shape, okay, bead up. But if you add detergent, what basically it does is it spreads the water. So that's why we need detergent. So mainly there are two types of detergents you'll be learning, okay? The first type will be soapy detergents over here. Now soapy detergents are basically soaps. Those solid rectangular blocks that some of you might use, like Dettol. Those are soaps. And they're actually made from natural fats and oil. Where the other type is soapless detergent, okay, which is derived from petroleum. Do you have to know this? Yes. Okay, this part. You have to know this, memorize it. You have to know where it comes from. So the easiest way to identify a soap is coming from fats and oils. You can see the shape. And this one over here are the liquids. So you can see those shampoos and whatnot. And this. Okay, so now you know there are two types. Now we'll learn how do these detergents help water to clean. And please highlight these two. The reason why detergent can help remove dirt or oil is one, it's act as a wetting agent. Now what is a wetting agent? Basically it helps water to be wet. Yes, it sounds stupid, but that's pretty much it. Okay? And the next one is emulsifying action. Now emulsification, if you're biology students, you have learned this already, but if you're not biology students, so please pay attention. Emulsification or emulsifying is basically allowing oil to form droplets. So if you have a stain, it's really hard to remove. So what detergent does is that it helps to emulsify. Okay, we'll learn more about it in a bit. And next, the structure of a common anionic detergent. Okay, so let's have a look over here. So simplification drawing. So we have two parts, the tail and the head. Now the tail, it's actually called hydrophobic hydrocarbon tail. Okay, so how do we memorize this? Hydro means water in this case. Okay, phobic means hate. So hydrophobic, water hating. Hydrocarbon, because that's what's made of, C and H only, and it's a tail. This part is the head. So hydro, again, water-philic means like. So water-like anionic head, because it's an ion. So let's have a look at it. So typical soap particle, all right? So the soap looks something like this. Have to memorize this? No. Able to identify this? Yes, you need to. So this is the tail. You can see it's only C and H, hydrocarbon. And this part you will notice COO and then K. So this part is a salt actually, but you can see COO. It comes from an acid. So the negative is basically the reason why we call it anionic, because this part of it's hydrophilic. Philic means like. So that means this part will dissolve in water. Okay? So if you know why, it's because it's negative. Negative means it's polar. If it's polar, like dissolves like. So this is not in textbook mentioned over here, so you might want to write it down. So let me repeat again. The reason why over here, why it's called hydrophilic, is because it dissolves in water. So polar. So this molecule is polar. So therefore, like dissolve like. So it dissolves in water. Whereas this part, as you can see, it's non-polar. So therefore, that's why it's called hydrophobic. That means it's insoluble in water, or it's water hating. And this one is water liking or loving. Okay, so you can see this one has been asked in CE only, not yet in DSEs. So perhaps your year. Okay, now moving on to another type. Soapless. What contains in those shampoos or conditioners or whatnot? The main difference is the anionic hydrophilic head over here. So the tail is basically the same. No matter how complicated it looks, it's still hydrocarbon. I would like to pay attention over here. Highlight these two, please. The reason why I'm not highlighting this book is because it's not mine. So sulfonate group and sulfate group. So the main difference is this C is connected with OO, 3 O's. Okay, so it's SO3 negative. So this one is SO4 negative. Okay, so this one is basically SO3, and this one is SO4. Now, why did they not call this sulfite? Again, it's just naming. All right, so hydrophilic and hydrophilic head. Do you have to memorize this? No, just you have to know that soapless detergents have these two groups, sulfonate and sulfate. Whereas soap, typical soap, is just a COO negative group. Okay, over here. So just you have to know this. All right, so now we have learned what are the chemical structures that allow this detergent to work. So now we'll look at the properties. How will it in atomic level work? So wetting property, the first one. As I said, detergents have two properties. One is wetting property and one is emulsifying property. So let's talk about in normal. Now this one is water. These are water molecules, and water droplets will be holding them together. So because of the high surface tension, the forces between water molecules, okay, hold them into a drop, okay? And what does the detergent do is it helps to break this down. So let's look at the picture at the bottom. And sorry. Over here you can have a look. Is that the detergent is over here. So you'll notice the hydrophilic head dissolves in water. So like dissolve like, that's why it's facing inwards. The tail is facing outwards because the tail cannot dissolve in water. So what happens is that these detergent will try to break the forces, all right, reduce the forces between the water molecules. So what happens is this is the break, and then they break open and the water will no longer be in droplets. Okay, so this is a property of wetting agent. Now let's have a look over here. Again, CE has been asked. For now, you don't have to memorize this. Just look through it. All right. So basically, the keyword will be number one. Large number of detergent particles tend to stay at the surface with their hydrophobic hydrocarbon ends sticking out. All right, and basically, the detergent particles separate the molecule, decreasing the attractive forces between them. So just highlight attractive forces, so it no longer beads up but spreads. So you don't have to memorize it, just get the idea of it. All right, that's basically wetting property. All right, next will be the emulsifying property, which is a bit more important than wetting property. Emulsifying property. Basically, you need oil and water. So if I don't mix them, it looks something like this. So normally you'll see a layer of oil above water. And if I add detergent, the hydrophilic head, hydrophilic, that means water-like, will be facing dissolved in the water side. Whereas the hydrophobic tail will be dissolved in the oil, because oil is non-polar. So non-polar will dissolve non-polar stuff. So like dissolve like, or unlike dissolve unlike. Okay? So that's the reason why it's this position. Now what happens is that after I shake it, the water molecule will start to go closer. And since like dissolve like, the droplets will, the oil will form droplets. Now why will they not form back into layer is because the charge. Because of the anionic property, once they form droplets, they will no longer open up again to form layers, is because they will repel each other. Okay, this is the most important part over here. So when you look at this paragraph, the detergent particles prevent the oil droplets from coming back together. So you can see the explanation is over here because they repel each other and prevent oil drops from coming together. So just highlight this part please, this line, the detergent particle blah 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 until together. So the oil droplets remain suspended, and that's the reason. So before and after shaking. So that's the emulsifying property. So now you have learned two properties. Now how does the cleaning work, the cleansing action of the detergents? So you have to memorize this. For now, no. But again, if I ask you to arrange the diagram, you should know how. And you should know, basically have the idea. But once you understand the concept of emulsifying, you will know how it's happening. So let's have a look at this one. Now this is grease and dirt over here. And I have water and detergent particles above here. Now it's sticking between the surface of a cloth. So no matter how much water you use, it will not come off. Like normally you do when you have an oil stain on your clothes. If you put water, it's no help. It just makes it worse. It just spreads the oil. So what happens is that there's no attraction between the water molecule and the grease. So what happens is I add detergent. What happens to the detergent is it will automatically, since grease is non-polar, okay, that's why water doesn't work. So the non-polar tail, which means hydrophobic tail, will dissolve in the grease, whereas the hydrophilic anionic head will dissolve in the water. And then what happens is water molecules attract the hydrophilic anionic head. So what happens is, because this is all water, it starts to pull towards itself, towards the water. So this starts to move out from the cloth. And then eventually, very similar to this part, it comes out. So once I stir or shake or rub it out, it forms oil droplets. So it does not come back together again, is because of the repulsion due to anionic heads of the detergent particle. So that's how basically it works in the microscopic level. How does dirt and oil get rid of it? So this is the first part. I hope you basically understood what I said, which is relatively common sense. So watch the next video for part 2.